Now that you looked at the motor effect, we're going to check out this section of the syllabus in more detail. Remember, electromagnetism packs a lot of stuff in these dot points, and so we've got to unpack it all. We've got to understand the subject-specific terminology. We've got to understand all the possible interpretations of these statements, because in the physics course they like to test you in a variety of ways. So let's delve a little bit more into this one. Investigate qualitatively. So here we're going to be looking at just descriptions. It then says quantitatively, so we're going to be using numbers and formulae, etc. The interaction between a current carrying conductor, right? So that is a very important, and uniform magnetic field. And so there's our formula. Okay, and then we've got some conditions we're going to be looking at. So in this video here, we're going to be looking at where does this formula come from. Now, even though this doesn't say derive the formula, we're going to derive it, right? But because one of the skills that is really important in the HSC physics now is deriving equations and understanding where they come from. So what have we looked at previously? Well, previously we were looking at this section here. We were looking at the movement of a charge through a static external field. And when we did that, remember we came up with this equation. We said that the force that that charge experiences is proportional to Q, the charge, proportional to its velocity, which was at 90 degrees to the field, and the strength of the magnetic field. And remember we said in most cases the particle was coming in at 90 degrees to the field, and then it underwent circular motion, etc. So this is what we looked at before. Okay, so if we were to think along the lines of like this charge is really just an electron, or a positive, we're going to deal with conventional current here, a positive charge going through a wire. So think of all these little charges moving through this wire here, okay? And the distance it moves through, right? Now the distance it moves through is related to the velocity. Okay, so remember velocity is displacement divided by time. So if we talk about its displacement is L, the length of this is L, and the time, then we can substitute this into our formula. So let's do that. So it's F equals Q. Instead of V, we're going to have L over T, B sine theta. So that's going to give us, that's the same as saying QL over T is B sine theta. Well, we could move the L out the front and then have Q over T B sine theta. Okay, and if we realize and remember that Q divided by T is just amps, the amperage, the current, right? Because remember, the current, I, is a measure of the number of coulombs moving past a certain point in time t. Okay, and so that's coulombs per second, which is equal to amps, right? So here, we're just saying this is the current. So if I then go L, I for current, B sine theta, and that's what we have up here. So really, the equation we're looking at before in terms of the force experienced by a charge as it moves through a conductor is pretty similar to the force experienced by a wire, a conductor, because really all the conductor is just the movement of charges through the field. And so this is the formula here that's provided in the syllabus, right? So we can see it right there. And notice that when you see it, it's at 90 degrees. When the current is at 90 degrees. Remember before we said in the previous formula that the velocity of the particle was at 90 degrees? Well, it's the same thing there. As we've just shown, that velocity is the same as the current, and therefore the current is at 90 degrees. So that's how they get that. Now something to be really important to I guess reinforce here is the length of the conductor has to be within the field. Now I haven't done that with my diagram here just because of my limited graphic design skills, but I'm saying pretend that this length here is all within a field. Okay, alright, so let's check out our formula now. So this is our formula that's in the syllabus. we've just derived it. We know that I represents the current in amps. Now just watch out for any traps, because sometimes they may give you the current in microamps or milliamps, so you have to convert that to amps before you put it into this equation. Then we have the length of the wire in meters. So once again, watch out for the traps where they might give you to in millimeters or centimeters. Convert it to meters. The magnetic field strength is in Teslas. And then we have the angle here, and the angle is between the direction of the wire and the field, and we saw that before, right? So if we have two examples here, right? If I was to draw, let's do a green conductor. So if I was to draw a conductor like this, then the angle between the field and the conductor is 90 degrees. Let's change that. Let's just zoom in so we can see it. That's 90 degrees, and the sine of 90 is 1. And so if the conductor is stationary like that, then that's the 90 degrees there. If, however, the conductor is not 90 degrees, let's say it's some other degrees, like this, right? Then that is when you have to put another angle in, I should say, right? So, and we're going to look at that in the next video, make sure you really understand that. But this is the formula, and we have to think in terms of 3D here. So I'll see you in the next video where we break this down, because the next video is all about watch the angle. It's all about the angle, okay? And I'll show you some tricks with that one. Right, see you then. Right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.